In this video, I want to have a look at equations reducible to quadratics. So what that means is that sometimes we'll get an equation that we're asked to solve and it doesn't immediately look like a quadratic equation, but if we make a substitution, then it becomes a quadratic and we can solve it and then figure things out a little bit later on. So we're going to jump straight into a few examples. Our first one is x to the power of 4 minus 7x squared minus 18 is equal to 0. Now at first it doesn't look like a quadratic because it's got that power of 4 and then a squared here. But the substitution that we can use for this, we're going to write let u equal x squared. So it doesn't have to be u, you can use whatever letter you want. But if we let u equal x squared, then that means that u squared is equal to, well, x squared squared, which is just x to the power of 4. So that's our first term then. So what this whole equation becomes then is u squared minus 7u minus 18 is equal to 0. So now this does look like a quadratic and it's one that we can solve relatively easily by factorising. So we've got our two brackets and our u's. We need two things that multiply to give minus 18 and add to give minus 7. So that's going to be minus 9 and positive 2. So if you need to, off to the side, you can use the PSF method or the cross method or whatever works for you to figure out that factorization. But then what that means is that either u is equal to 9 or u is equal to minus 2, because one of these brackets has to be equal to 0 to get an answer of 0. So now we know what u is, but actually what we wanted is we wanted to figure out the values of x that make that equation true. So we're going to substitute back in. We know that u is equal to x squared. So that means that x squared is equal to 9, or x squared is equal to minus 2. Now if x squared is equal to 9, that means that x is either equal to plus or minus 3, because we're taking the square root of 9. In this one, if we want to get rid of that squared to get the x on its own, we'd have to take the square root of this side. But because that's a negative 2 and we can't take the square root of a negative number, we're going to have no real solutions on this side. So there are two solutions to this equation. We've got x equals plus or minus 3. What that means is if you graphed that curve, so y equals x to the power of 4 minus 7x squared minus 18, you'd have two x-intercepts or zeros or roots, and they would be at plus or minus 3. In our second example, we've got x minus 2 all squared plus 7 outside of x minus 2 minus 30 is equal to 0. So this one does maybe look a little bit more like a quadratic to start with because we've got that squared term that we're used to at the start. But what we've got that we're not used to is this x minus 2 in here. So we're going to, in this one, we're going to write our substitution as let u equal that x minus 2, so that whole term in brackets. So that means this equation is going to become u squared plus 7u minus 30 is equal to 0. Now we can factorize that, again, using whichever method works best for you. But two things that multiply to give minus 30 and add to give 7 would be plus 10 and minus 3. So that means that either u is equal to minus 10 or u is equal to positive 3. Now that we've got our answers for u, we're going to substitute back in what our substitution was initially and then solve for x. So that means either we've got x minus 2 is equal to minus 10 or x minus 2 is equal to 3 and then solve both of those equations. So we'll end up with x is equal to minus 8 or x is equal to 5. So they're the two x values that satisfy that equation. Okay, our last example, we've got 4 to the power of x minus 9 times 2 to the x plus 8 is equal to 0. So this one might be a little bit trickier to see what our substitution should be straight away, but we're going to let u equal 2 to the power of x. So that gives us this term here, so that will just become a 9u in the middle. But it still might not be clear how we get to that 4 to the power of x there. So if we have u squared, that's going to give us 2 to the power of x all squared, which is the same thing as writing 2 to the power of 2x, which if we undo that step, we're writing 2 squared to the power of x, and we know that 2 squared is 4. So u squared is the same as 4 to the power of x, even though it might not be clear straight off. Okay, so what that means for this equation is that we're going to have u squared minus 9u plus 8 is equal to 0. Again, we're going to factorize this using whichever method works for you. So that means we're going to have 8 and 1, and to make that 9 a negative and that 8 a positive, they're both going to have to be negatives, which means we'll have u equals 1 or u equals 8 as our solutions. So we know what u is, now we sub back in our x. So we're going to have 2 to the power of x is equal to 1, and 2 to the power of x is equal to 8. Now we've got to figure out what number goes in here to get an answer of 1. So the only way that's going to work is we need to remember our rule for indices, that anything to the power of 0 is equal to 1. So if that x was a 0, we'd end up with 2 to the power of 0 is equal to 1. So one of our solutions is x equals 0. The other one, we need to know our powers of 2, and 2 to the power of 3 is 8. So we'd have x is equal to 3. So again, we've got two solutions that satisfy that equation. So that's a quick look at how we can reduce equations to quadratics to be able to solve them.